All right, so I'm really grateful for this award. It means a lot coming from this community, which has been really important to me. I wanted to tell a little story about some of my experiences in art and computing. I want to start by telling you about how this book changed my life. So when I was in college, I was interested in lots of things. I took courses in philosophy and literature and a bunch of art courses. But because I was planning to major in computer science, I had to take some generic humanities distribution courses. And in one course, we were assigned to read this book and to write an essay on it. And I started reading it, and I just did not want to read this book. I didn't want to write the essay. I didn't like the class. So I found a way out of it. All I had to do was to double major in art and take 3 more years of art classes. And that's what I did. And to this day, I've still not read the book. So here's a self-portrait that I painted during one of those courses. And I found the instruction to be kind of intuitive, like not really based on principles per se. So for example, one day I brought this painting into the studio, a watercolor, and the professor says, "So why did you draw paint that street sign?" I said, "Well, because it was there, because I wanted to paint what I saw." But so then I wonder, shouldn't I not have painted it? How do I decide what do I paint? What do I, how do I make these decisions in general? Or if he liked what we brought in, he would say, "Oh, that's kind of interesting," and praise the mark making or the gesture, and so on. And so I feel like out of all my art classes, I came away with good intuitions and experiences, but no theory or principles whatsoever. How do you think about composition or perspective, or what does it even mean to be an artist? So I went to grad school in for computer graphics, and when I said I was doing this, lots of people said, "You should go to SIGGRAPH." And so I did, drove down to New Orleans for SIGGRAPH 96, and it was so cool. Oh my God, there's all of these new ideas and new approaches for how to do things, new algorithms, but also lots of big feature films and technical reels, and also weird experimental abstract animations, and I loved all of it. It was so cool, and this is where I wanted to be. So in grad school, of course, I have the question of what research do I do? And I played around with some ideas the first year. But then the pivotal moment came at SIGGRAPH 97, where I sat in a talk by Pete Litwinowitz, and he described a method for making a painting from a photograph by placing a grid of brushstrokes over it the way an artist would. And I sat there thinking when he said that, well, that's not how artists work. At least that's not how I would paint. And so I went back to the lab and I implemented his algorithm, and I started making a bunch of changes to it. And within a few months, one of my lab mates said, "Oh, it's cool, you should send it to SIGGRAPH." And so I did, and it got in, and that was my first SIGGRAPH paper. And that set me on the path towards doing my PhD in non-photorealistic rendering. I'll mention one other paper from my PhD. So at SIGGRAPH the following year, I saw this short film called Snack and Drink by Bob Sabiston. And I really loved the kind of interesting sort of rotoscope kind of look. I could sort of imagine how it was done. And it seemed really interesting. And so the following year, when David Salatin hired me for an internship and asked me what I wanted to work on, I thought, well, we could do something like that. We could track motion and video and have artists draw strokes over frames and propagate their strokes to the next frame based on all these different sources of input. And as we were discussing this, we thought, well, actually, if we could do that for strokes, we could do it for images too. And that became the paper, a method for stylizing images based on example paintings or other artwork instead, rather than coding up all these stroke generation procedures the way we had been doing it before. And once you get immersed in a problem, then you start to see connections with it everywhere. So one day I was in a friend's office, and I saw on the wall this painting, and it just immediately clicked. Of course, we could just plug that into the algorithm, draw a guidance image, and then make more images based on that example. And indeed, Chuck Jacobs implemented an interactive version of this where you could paint textures based on textures in a source photograph. And he was a co-author along with Nuria Oliver and Brian Curlis. So one of these, one of the things to note here is that it isn't just we start with a problem and then we publish a solution. There's a whole bunch of different things that happen along the way. What we published in the end was just totally different from the initial inspiration and idea that we started with. Now, after my PhD, I didn't do a whole lot of work in non-photorealistic rendering for the next few decades, in part because I was really excited by other things, and character animation and geometry processing and computer vision, did a bunch of stuff there. but also because it was a little bit hard to know what to do next. Like we it sort of felt like not really sure what problems to work on or how to approach them. And then there were a few different things happened eventually that spurred new activity and also sort of set me on a path towards being able to sort of answer for myself some of those questions I had had back in college. So the first thing that happened was the rise of AI art starting around 2015. There's Deep Dream and neural style transfer and generative adversarial networks. And suddenly a lot of people at AI are talking about AI art and in the media and art institutions. And I found the dialogue, frankly, a little frustrating. We in computer graphics have been making art with computers for decades, and we've heard it all before. Like I've heard people say the Pixar movies are just made by the computers and stuff like that. And I wanted to bring some of that computer graphics experience to this discussion. But I wanted to have a more conceptual, more grounded way to think about it. So I went back and I read a pile of books on history of art and philosophy of art and sociology of art, and spent more time going to galleries and a lot of time talking with artists. And all that culminated in this paper in which I tie together these threads of computer graphics and generative art and conceptual art and sort of articulate this view, which I view as the conventional wisdom of SIGGRAPH, that computers are tools that we use to make art and communicate. I also wanted to sort of communicate a little more broadly about some of the history of NPR, because it felt like a lot of people felt that stylization started in 2016. And so I wrote my first blog posts about this history. And as I was reviewing the literature and revisiting the line drawing algorithms, and there was this idea of line drawings as abstracted shading, that we can generate line drawings by approximating a particular kind of realistic shading. And I wondered if this had been picked up at all in the human vision literature, and it hadn't. And so, long story short, I ended up writing a paper in the human vision literature arguing that there's an answer to the question of why do we perceive shape in line drawings when they're not part of our natural world? And my hypothesis is basically that our human vision system is treating these line drawings much like these computer graphics renderings from the suggestive contours and abstracted shading literature. The other thing that happened was I bought an iPad, and I bought an Apple Pencil and tried it out for the first time. And I sat on my couch and drew this little sketch of one of my houseplants just to see what it was like, and it was so much fun. And suddenly, I just wanted to spend all my time drawing. So I had not been painting for 20 years, and now I was taking my new iPad everywhere and drawing pictures. And as I did this more and more, I started to see how a lot of the assumptions I had had about making art were wrong, and things that had built up over the years and for various reasons. So for example, one day I sat in front of this building and I thought I'll make a detailed, realistic watercolor painting of it like I had done in college. And I was still kind of learning the watercolor tools. And partway, after a while, it's at this point where I was very frustrated. I didn't like how it was going. It wasn't what I had wanted. So I thought I'll try something different. I'll draw some black strokes over it, and I did. And I was happy with the results. Friends I showed it to seemed to like it. And so the point here is that according to my original goals, this is a failure because it's not a detailed, realistic watercolor, and yet I was perfectly happy with it anyway. It may not be a great work of art, but I view it as a success. And even now, with 5 more years of practice drawing pictures, every time I draw a picture, it's still a surprise what comes out. I can't predict what it's going to look like in the end. And so I think we have this myth in our society that what an artist does is executes on a vision. Adriana talked about this as well, that we think that you have an idea, and what you do is you implement that idea. And the more I've read the works of famous artists and writers and musicians, what really happens in a lot of cases is it's an exploration. You start with an idea or a plan or just some spark, and you start doing stuff. And as you start doing a thing, start painting a picture or composing music, something happens. You have a thing and you respond to that thing, and your idea changes along the way. And you might end up very, very far from where you started and discover something really new. And this is the same thing that happens often in our research papers, that we publish something really different from the idea that we started with. And of course, quite often in our research careers, that you can't plan what your career is going to be. One thing leads to another, which leads to another, and so on. And I like open-endedness as a term that describes this sort of this concept in opposition to optimization or planning. And often I think the most impactful art and research comes from exploration, not sticking to a plan. Because when you're exploring, that's when you can discover something. If you have a plan, you're not going to discover anything new necessarily. And for graduate students learning to do research, there are many different skills to develop around this, including partly just curiosity, being interested in lots of things, learning lots of stuff, and also intuitions for when is there, like, oh, this is an interesting thing to try. Maybe we should try that and see what happens. Or this is not working out. Should we give up or not? Now, all that being said, I do want to say that often we do achieve our plans in our research. We do publish a paper on the thing that we more or less set out to solve, and that's good too. I think most research is probably like that. And I actually think most research is incremental. I think in the SIGGRAPH community, we often treat incremental like it's a four-letter word, and I believe that incremental research is really important as well. The other thing that happened another thing I noticed when I started painting was I would paint a landscape like this, and then I also take a photo at the same time so I have it for reference later, I can compare it, whatever. And my gut reaction, my initial impulse when I see these side by side was, they don't look the same, my drawing doesn't look like a photograph, therefore I'm a bad artist. But that made me then do more looking at how does the picture on the screen compare to what I see around me? And actually these are really different too, in the space and the colors and the tones. And it's sort of like thinking about this more, I came to really think of everything we're doing in pictures as a bunch of choices. You decide what do you add, what do you take out, how do you arrange things in a picture page. These are all choices a painter makes. And I also wrote this piece arguing the philosophical point that the same thing is true for photography. Everything that happens in a photograph is the result of choices either by the photographer or the camera manufacturers. There's no such thing as a right or a correct or proper picture. And this point I make in the paper is very much illustrated in many examples from the SIGGRAPH literature, since so many of techniques from SIGGRAPH are basically used by lots of cell phones. But that being said, even though there's no right or wrong pictures, different pictures lead to different percepts and different impressions, responses in a viewer. And I wanted to understand this further. So again, I went back to literature, the philosophy of perspective, the history, the psychophysics and neuroscience perspective. And after about 3 or 4 years, I ended up with this paper, and this is the work I'm most excited about right now. That I know we always say this, but this is my best work because it's my most recent. And in this work, I'm presenting a theory of perspective, which is based on, inspired by, in part, the graphics literature on multi-perspective projection, which shows that you can get very effective imagery with different perspectives and parts of the picture. And the main hypothesis, that I'm proposing here, is that human vision, when we view pictures, perceives pictures as having separate perspectives in each eye fixation. So as you move your eyes around, you're seeing a bunch of little pictures which you sort of mentally, abstractly stitch together in your head. And I feel like this is answering questions that people have had around perspective for 500 years. But I don't want to oversell it. So now I'm really excited about extending these ideas and thinking about how intuitions that we have from computer graphics, as well as recent results in neuroscience and vision, can help us understand human vision better. How do we perceive and parse the 3D world, and how do we understand what is going on in pictures? And likewise, I think that better understanding of these things will enable new graphics and imaging algorithms, because we'll have a better idea of what makes things look right or how they get perceived. So I want to suggest a notion of how do we define computer graphics research based on some of this. Ever since I've been attending SIGGRAPH, I feel like there's been a little bit of insecurity around, like, are we just the R&D arm of the entertainment industry? And I do feel like, I very much believe in the engineering goal of SIGGRAPH. We are building tools for visual art and communication, for scientific visualization. I think this is incredibly successful. But there's something else that's also happening here. There's an overlapping goal of building scientific models of pictures and video and other visual imagery. And the last few papers I just described are examples in which I'm proposing scientific theories of perception heavily inspired by models and insights developed in computer graphics. So in short, I believe computer graphics can help us make new kinds of art and expression. It can help us understand the science of art and of human vision. And it can also help us understand what it means to make art with computers and defend against some of the AI hype, because we have all this experience of making art with computers for many decades. I have many colleagues, friends, mentors to thank for this award that I'm really grateful for. I mentioned a few this morning, but I'll mention my PhD advisors, Ken Perlin and Dennis Soren. David Salison hired me for 3 different jobs. I have a lot of really frequent collaborators, and even though, despite what I showed here, I feel like a lot of my best work is done in collaboration, including people with David Fleet, S.C. Margawala, Zoya Belinsky, Steve DeVerde, Sylvain Paris, Ellie Sheckman, and thanks again to everyone at SIGGRAPH.